Hi everyone. Today topic is inductive effect. Inductive effect. It is also called as polar nature of covalent bond. It is taken from some basic principles of organic chemistry, grade 11th. Electrical effects. The electrical effects are mainly divided into following categories. Inductive effect. First one is inductive effect, polar nature of covalent bond. What is inductive effect? Why we talk about polar nature of covalent bond? The word polar means charge separation. Polar nature means it can be divided into polar atoms, anion or cation. Covalent bond. Covalent bonds means transfer of electrons. One atom to another atom to form a covalent bond. So, the inductive effect tells about polar nature of covalent bonds. What is inductive effect? The displacement of an electron pair along the carbon chain because of the presence of an electron withdrawing or electron releasing groups in the carbon chain. It is known as inductive effect or I effect. Once again I repeat this. What is inductive effect? The displacement of an electron shared pair along the carbon chain because of the presence of an electron withdrawing or electron releasing groups in the carbon chain. It is known as inductive effect. Inductive effect are also known as I effect. See here, in this carbon chain containing 3 carbons and G is the functional group. The shared pair of electrons towards functional group, so the G carrying negative and carbons are carrying partially positive charges. And the next one, see here, the electrons towards the carbon atom, so G is positive nature, so the carbons are negative, partially negative charges. But the effect is insignificant beyond the third carbon atom. This effect is transmitted through the chain of sigma bonds and diminishes with the increasing chain length. The inductive effect is a permanent effect, and the electrons never leave their original atomic orbital. And next one is it operates through sigma bonds only. The polarization of electrons is always in single direction. It is generally observed in saturated compounds. Saturated means only sigma bonds, no pi bonds. So, the inductive effect is generally observed in saturated compounds like alkanes, cyclohexanes, like this. And its magnitude means electron withdrawing or electron donating power. So it decreases with increasing distance. Distance will be increases. So the magnitude will be decreases. They are inversely directly proportional to each other, magnitude and distances. On the basis of inductive effect, these are all the points. Permanent effect, electron never leave their original atomic orbital and it operates through sigma bonds only, and polarization of electron. All these points the groups can be two types, minus I group and plus I group. The minus I group, the group that withdraws electrons, is known as minus I groups. That means the electron withdrawing group is negative I group. So, and its effect is known as minus I effect, negative inductive effect. The minus I Power of various group and cation is NF3 cation is greater than NH3 ammonia and NO2 greater than CN greater than SO3H greater than and aldehyde group greater than CO ketones and acids greater than acid chlorides greater than esters greater than amides greater than fluorine greater than bromine chlorine greater than and bromine greater than I greater than iodine and OH greater than OR greater than NH2 greater than carbon 3 C triple bond CH greater than and benzyl C2H5 greater than and CH double bond CH2 greater than hydrogen. The negative I power groups and decreasing order with respect to reference hydrogens. And next one is the plus I group. Plus I group means positive inductive effect. The group that donates or gives electron is known as plus I group and its effect is known as plus I effect. The plus I effect is the actually alkyl groups and O minus and CO minus are plus I group. These are electron donating groups. NH greater than O minus greater than CO minus greater than tertiary alkyl greater than secondary alkyl greater than and primary alkyl greater than methyl greater than hydrogen. These are the plus I power in decreasing order with the reference to hydrogen. So and in plus I group, the first one is different types of groups and anions and the second one is plus I power same type of alkyl groups. In case of same type of alkyl groups, so the inductive effect will be how to vary positive I power. The positive I power is directly proportional to number of carbon atoms. That means the number of carbon atoms increases, the positive I power will be increases. I power greater than inverse directly proportional to number of carbon atoms in the same type alkyl groups. CH3 single bond CH and CH3 single bond CH2 single bond CH2. And these are the positive I power increasing order. And next one is the applications of inductive effect. What are the indicative applications of inductive effect? The first one is strength of carboxylic acid. Strength of carboxylic acid. Strength means the pKa values. And next one is acidity of alcohols. And next one is basicity of amines. And fourth one is stability of non-conjugated cations and anions. The first one is strength of carboxylic acid and second one is acidity of alcohols and third one is basicity of amines and fourth one is stability of non-conjugated cations and anions. These are applications of inductive effect. Now I want to explain about one by one applications. So the first one is strength of carboxylic acid. In strength of carboxylic acid, the one of the application of inductive effect, the acid strength is measured by the position of equilibrium of ionization of water. The water molecular formula is H2O. And ionization of water means H plus and OH minus. So, the acid strength measured by the position of equilibrium of ionization of water. So, it can be changes RC double bond O and OH. It can be ionization to form O minus and H pluses. So, further the ionization goes to right and the greater the acid strength, it is the equilibrium reaction. So, the Ka equal to rate of products by reactants. In products, RC double bond O minus by concentration brackets RCOH acid. Acid strength is directly proportional to Ka but inversely proportional to pKa values. The acid strength inversely proportional to concentration of anion and acid strength is directly proportional to stability of acid anion. Thus, the strength of acid is the function of stability of acid and anion. So, the inductive effect of acidity can be summarized following like this. Electron withdrawing groups, here electron withdrawing is the alkyl groups CO double bond O and OH. So, the direction towards the electron withdrawing groups. So, it carries positive charges. Electron withdrawing group stabilizes acid anion and strength of acid, or negative I group increases strength of acid. So the strength of acid is directly proportional to minus I power of the group present on COH. And for example, electron donating groups, we can observe in electron donating groups, so the bond polarizes towards the carbon side. Electron donating groups are the minor plus I groups. So it destabilizes acid anion and weakens the acid, or plus I group decreases strength of acid. So the strength of acid is inversely proportional to plus I power of the group present on COH and directly proportional to minus I power of group. Like this. For example, consider following homologous aliphatic acids. The acid strength in decreasing order, so the power of alkyl groups also increasing order. That means the number of carbon atoms in the chain increases. Acid strength will be decreases like this. And next one is acidity of alcohols. The acidity of alcohols depends on the stability of alkoxide. Alkoxide means RO minus, alkoxide ion, that is conjugate base of alcohol that is obtained by the dissociation of alcohols. That means ROH is equilibrium reaction, so it can be ionization. So the bond will be broken, the bond will be towards the oxygen side, the bonded electrons towards the oxygen side, it will get a RO minus and H plus. That means the acid strength of alcohol directly proportional to stability of alkoxide ion. These are the acidity of alcohol. And next one is basicity of amines. Basicity of amines. The basicity is defined as the tendency to donate electron pair for sharing. The difference in the base strength in various amines can be explained on the basis of plus I effect. The groups producing plus I effects tends to intensify electron density over N in amines, thereby producing a base strengthening effect. So, the strength of base directly proportional to plus I power of group present on NH2 and Kb and pK. So, the strength of base is directly proportional to strength of base. So, NH2 is directly proportional to Kb and NH concentration of base and acidity pKa means the strength of the base. So, NH2 is directly proportional to Kb and inversely proportional to pKb. That means whereas the NH2 will be increases, pKb will be decreases. That means that weakens the effect. Thus, strength of base is directly proportional to 1 by minus I power of group present on NH2 and directly proportional to Kb. And the alkyl groups will be number of alkyl groups increases, the relative base strength is like this. And fourth one is stability of non-conjugated cations and anions. And And the fourth application is for inductive effect, the stability of non-conjugated cations and anions. Non-conjugated cations and anions, the stability will be compared by the following rules. The first one is stability of alkyl carbocation, and second one is stability of alkyl carbanion. Stability of alkyl carbanion, and next one is stability of alkyl and vinyl carbocation, and fourth one is stability of alkyl, vinyl and acetylenic carbanions. These are the 4 steps to observing stability of non-conjugated cations and anions. The stability of non-conjugated cations and anions, the charge species can be compared by the following rules. The first one is, the rule 1 is lesser magnitude of charge and higher the stability of charge species. And rule 2 is, for a maximum stability, the positive charge should be present on electropositive atom in cation, or negative charge should be present on electronegative atom in anion. So this rule can be used in those cases. That means what they are rules. The first one is the lesser magnitude and discharge, magnitude of the charge and higher the stability of charge species. So the magnitude of the charge will be decreases, the stability of charge will be higher. Lesser magnitude and higher stability of the charge species. For the rule 2 is, for a stability of non-conjugated cation and anion, for a maximum stability, the positive charge should be present on electropositive atom in cation, or negative charge should be present on electronegative atom of anion. So these rules can be used in those cases where hybridization of atoms bearing charge is different. The stability of cation 1 and third one and second one and third one can be compared by this rule. The first one is stability of alkyl carbocation. The stability of alkyl carbocation will be inversely proportional to magnitude of positive charges. The magnitude of positive charge will be inversely proportional to power of group. Power of group means the alkyl groups. From 1 and 2, the stability of alkyl carbocation is directly proportional to plus I power of the carbo group present on C+. Thus, tertiary alkyl carbocation is more stable than the secondary and then more stable than primary carbocations. So, in all those cases, the number of plus I groups on C plus is an increasing order, and plus I power on C plus is increasing order, and magnitude of positive charge is in decreasing order. So the stability is in increasing order. It is the stability of alkyl carbocation. And next one is stability of alkyl carbanion. The stability of alkyl carbanion is inversely proportional to magnitude of negative charges, and magnitude of negative charge will be directly proportional to plus I power of the group, that is alkyl group stability of alkyl carbanion directly proportional to 1 plus I power of the alkyl group present on C minus. So for example, H single bond CH2 minus and RH or CH2 minus or CH minus R, and this is the methyl carbanion, primary carbon, secondary carboanion and secondary carboanion and tertiary carboanion. So in this all those, the number of alkyl groups on C minus is increasing order. Plus I power on C minus is increasing order. The negative charge on C minus is increasing order. The stability is in decreasing order. So this is like this. The magnitude of negative charge will be directly proportional to plus I power of the group. Plus I power means the alkyl groups. So the stability of alkyl carbanion is inversely proportional to plus I power of alkyl group present on C minus, like this. And the third one is stability of alkyl or vinyl carbocation. The stability of alkyl and vinyl carbocation, the stability of these two types of species can be compared by this rule. CH3CH2 plus in this sp2 hybrid carbon atom. sp2 hybridized carbon is less electronegative values. So the positive charge is present on less carbon atom. In CH2 double bond CH, this is the vinyl group. In vinyl groups, the carbon is sp hybrid carbon and sp hybrid carbon is more electronegative when compared to sp2 carbon atom. So the positive charge is present on electropositive carbon. Hence, alkyl carbocation is always more stable than vinyl carbocation. This is the rule. And fourth one is stability of alkyl, vinyl and acetylenic carbanions. In alkyl carbanion and vinyl carbanion and acetylenic carbanion, all of those. In the alkyl carbanion having sp3 hybrid carbon and sp3 hybrid carbon is electropositive. So the negative charge is present on electropositive carbon. In this vinyl carbanion, the vinyl carbanion having the carbon is the negative carbon is a sp2 hybrid carbon and it is less and it is electronegative carbon. So the percentage of S character is 33.33. The negative charge is present on electronegative carbon. So it is a less electronegative. And next one is the acetylenic carbanion. In acetylenic carbanion, the hydrogen is the carbon is sp hybrid carbon and it is more electronegative than second. So because the percentage of S character is sp hybrid carbon 50%. So the negative charge is present on more electronegative carbons. Hence the acetylenic carbanion is more stable than vinylic carbanion, that is more stable than alkyl carbanion. This is the inductive effect. The inductive effect is the polar nature of covalent bonds. So the displacement of an electron shared pair of electrons along the carbon chain because of the presence of an electron withdrawing or electron releasing groups in the carbon chain is known as inductive effect. The inductive effect can be divided into plus I effect and minus I groups. Minus I groups are the electron withdrawing groups tends to minus I groups and plus I groups having the groups donating electrons to it tends to plus I groups. Thank you. Please subscribe, friends. For more updates, please click bell icon